Planet Earth. If you look closer, you'll see that a whole other world exists beneath the surface of land and sea. Layer after layer of rock structures go deep into the Earth's crust, mile after mile. And trapped within these structures, along with other liquids and solids, you'll often find deposits of oil and natural gas, the world's two most important sources of energy. These famous fuels are in constant demand because they make the world go round, day in and day out. So how do you find something that's completely hidden beneath the Earth's surface? It's a mystery that people in the oil and gas industry are always trying to solve, and for very good reason. Drilling for hydrocarbons is expensive. And before they spend money on equipment and crews, exploration and production companies need a reliable strategy for pinpointing where to drill. Geoscientists have a secret weapon called seismic exploration, and it involves sending acoustic energy, which takes the form of wavelets, into the ground to get a sound picture beneath the surface. It's complicated, so let's start with the analogy of bats. Bats can't see very well, so they send out little waves of sound that bounce off of objects and then go back to their ears. It's called sonar. It gives them what you might call a sound picture of their world. That's a good example of how nature already uses a form of seismic acoustic imaging to locate objects. Doctors also use it for ultrasound imaging. Geoscientists use man-made tools to make the sound wavelets, listen to them, and then record them. When you want to know if oil and gas deposits are in a particular area, geophysical companies bring large trucks that have big vibrators on them. Most of the time, this is what generates the acoustic energy or vibration. They use geophones, or very sensitive seismic microphones, to hear the reflected sounds, but sometimes they set off small buried charges. They set many geophones on the ground in a line, and they are attached to a recorder inside another truck. The vibrators send thousands of wavelets down into all the different layers of the Earth. Some of the wavelets bounce off of the boundaries between the rocks below the surface and are reflected back to the geophones that are waiting to record them. Each geophone along the cable sends the received wavelets to the recording truck where they're recorded and stored. How do the wavelets reach into the subsurface of the ocean? That's offshore seismic, and it just requires a different device to send out the wavelets and record those that are reflected back. Out at sea, a seismic crew works off a vessel with a specially designed back end, so it's easier to lay floating cables or streamers. And all along the length of the streamers, microphones, called hydrophones, are attached one after another. Several of these hydrophone streamers are pulled behind the vessel at once. Acoustic sources are towed behind the vessel in front of the streamers and release compressed air, which creates the wavelets. These wavelets travel through the water and into the subsurface below, where, just like on land, they bounce off the rock layers and then return to the hydrophones to be recorded. Here's what seismic looks like after it's been recorded. Basically, it's a bunch of squiggles. There are still a few more steps to go before it begins to look like an actual picture of the Earth's interior. Right now, the data is still in its raw form. To get a picture that actually looks like the Earth beneath us, the data has to be processed. It takes a large supercomputing PC cluster to process the seismic data. These computers go through all the different traces made by the wavelets and filter out everything we don't need, such as vibrations made by a tractor in a field nearby. Using really amazing computer applications and working on state-of-the-art workstations, geoscientists can see the seismic data translated into a 3D picture. You might be thinking, I don't see any oil and gas there. But believe it or not, geoscientists can look at this processed data with their trained eyes and make an informed decision about whether or not oil and gas deposits are in the geologic structures. Seismic data leads to a high percentage of drilling success with less risk to the environment. And in a world where the demand for oil and gas is increasing faster than the supply, good seismic information will lead to more affordable energy.